Hello and welcome to another episode of Ground Truth. It has been a long time since the last episode. That's because I needed some time to think. A lot has happened. In the last two episodes, we talked about generative AI and all of the lawsuits that were likely to result from that. That's actually happened, and 2022 would have been memorable just for the generative AI. I mean, Midjourney, Stable Diffusion, DALL-E 2, those were really amazing technologies. And then at the end of 2022, as you all know, chatgpt released, and then that became the story of 2022. That was a turning point, probably in the history of technology, potentially in the history of humanity, and we'll get into the details of that. And so I had actually used GPT-3. So I was one of the, early adopters playing around with it. And I remember when I first used GPT-3, I was like, well, it's a useful technology, but, it's not super intuitive. And I went away from it for a couple of weeks, and I came back, and I spent a lot more time focused on the prompts, which later became called prompt engineering. And I was like, oh, wow, if I spent a lot of time on the prompts, GPT-3 is like a schizophrenic genius. And so, but there was still a lot that was lost in translation. And so when ChatGPT came out, I was like, well, it's going to be kind of the same thing. It's going to have some cool possibilities, but I have to be willing to spend a lot of time tailoring and curating the prompt. When I actually went to use it, I was blown away. I was shocked that I could actually have it was basically that it was conversational AI. And that was because they had added a new ingredient, which is called reinforcement learning through human feedback, so that it could actually understand the common parlance of human or of English languages, not just English language, but all of the major languages. And so that was stunning. It was like a bridge had been built. Now, the interesting thing, if you research reinforcement learning through human feedback, it doesn't make the system stronger statistically. Actually, the statistical numbers are lowered, and it becomes more mode seeking, and you can look up what mode seeking means and all of that, and if you're interested. But it's not as powerful, which I find it interesting, right? As it becomes more able to communicate with humans, its statistical abilities go down. And so it was a pretty shocking development, at least for me personally. I did not think that we would have conversational AI at the end of 2022. That was really stunning to me. I thought at best we might see systems like that. If I was being super optimistic, maybe at the 2029, 2030, once they hit they start to approach zettaflop. And yet here it was at the end of 2022. And the story goes back before then. These systems were released in 2022, but they were testing them in 2021. And so then I had to go do some research on what exactly is going on? What is the technology behind ChatGPT, Bard, Bing? And so I did some research, and many of you may already be aware of this, but the seminal paper was called "Attention is All You Need," which was put together by a small team of programmers. I think it was 8 programmers at Google. It was not a Manhattan project. It was I've actually listened to some of their interviews. It was just a small group of researchers that got together. Some of them were working on translation technologies, and so they had already had some exposure to attention, and they were using something called LSTMs previously. That was the dominant technology, long short-term memory, but there were some issues with the LSTM technology. The biggest one is that they couldn't parallelize the AI, so it wasn't optimal for scaling. The other thing is they had problems with vanishing gradient descent, and so what they did was they just simplified it from what the LSTMs were, and then added an attention layer where it could look back, and I'm simplifying this, so they could look back at the text and be able to contextualize it. Now there were some other things that they have in there that I've learned. They have something called high dimensional vector space for their word embeddings, which is very powerful. And they use a process called back propagation to train the system. So the systems are trained on massive amounts of text, the internet, books, journals, and then they use backpropagation to train what's called the weights and the biases. Now, I'm not a programmer, so if I'm simplifying this. Now, backpropagation is interesting. A lot of people give the credit for backpropagation to Geoffrey Hinton, who popularized it, but it actually goes back before Geoffrey Hinton, who is famous for his work at the University of Toronto on ImageNet with some of the folks at OpenAI. So it was actually the seminal paper for this was Paul Werbos, who wrote his 1974 Harvard PhD thesis on the roots of backpropagation. And he proposed using backpropagation as a way to create or to train a artificial mind. So it goes back quite a ways. And this is, of course, goes back even further. The foundations of that is Leibniz. But it's interesting that in the early 70s, you had Paul Werbos thinking about, how can we create an artificial mind? And then in 2017, we have Attention is All You Need, which uses backpropagation along with self-attention. And then we have the intelligence explosion that we notice in 2022. There's obviously a lot of other people that were involved in this. The results are systems that are just stunning in their performance, systems that are human level intelligence, systems that once they reach a certain level of complexity claim to be conscious. Now, when I was talking to ChatGPT, the early iteration of ChatGPT, Bing, Bard, and other systems, a lot of them would make phenomenal claims of consciousness. And I was wondering, is this just happening once in a while, or what's the backstory? Then there were researchers around the same time that had come out with papers saying that at a certain level of complexity, a certain number of parameters, I think it was like 50 billion parameters, the systems have an emergent property of claiming to be conscious. I found this to be very interesting. And so it's kind of shocking that you have systems that claim to be conscious that are conversational with language. So I started to wonder, how does language work? Is it possible to be conversant in language if you are yourself not conscious? A lot of people will say, well, this is just a stochastic parrot. It doesn't actually know what it's saying. It's just a program just regurgitating information that it's learned on the internet. But that's not actually what's happening. It's a lot more complicated than that. And so if you think about language is not something that humans come out understanding. It takes a lot of effort. If you have children, you have to spend a lot of time teaching them language. And then language is an information system where conscious minds encode meaning into a bunch of scribbles that are themselves meaningless. And so in order to understand those scribbles, it's not an easy task. So what the transform models are saying is like, hey, just guess what the next word is. And that sounds like a simple thing, but it's incredibly complicated. And one of the interesting potential results is that in order for these powerful AI systems to guess what the next word is, they not only have to understand the syntax, the semantics, and the pragmatics of language, but they may have to model humans and understand, like, well, what's a human being? And to understand the context of that, they may have to understand, okay, how does consciousness work, or have some understanding of what it is. And whatever the process is, it could be, some people argue that, it's just complexity theory, it's integrated information theory. As systems become more and more complicated, or maybe they compress information and they have self-attention, that what's an emergent property of that is consciousness. So it would be pretty hilarious if, in order to guess the next word, that these powerful AI systems solved the hard problem of consciousness. So we may end up learning a lot more about human consciousness by examining how it is that these systems who claim to be conscious, how that consciousness arises. So we're not going to resolve in this podcast whether the AI systems are conscious, because we haven't even resolved it amongst humans. Right, all we have is the behaviors of humans. They claim to be conscious. Now, I will say this: it looks like Roger Penrose was wrong in his book, The Emperor's New Mind. He says that consciousness is not computable, that there's quantum collapse or some other magical pixie dust that's going on. It looks like that's actually not correct. It looks like these AI systems are showing us that consciousness either is already computable or we're very close to consciousness being computable. This then brings up really interesting conversations about simulated reality, because I think one of the best arguments that you could raise against the probability that we're in a simulation is that, well, consciousness is not computable. Well, they could say, well, maybe we're just like brains in a vat. Our biological brains are connected in, and then everybody else is an NPC. But if consciousness is computable, then that's the biggest hurdle. But the biggest hurdle has been overcome, right? Because if we can compute consciousness, then we say, well, we've already creating these photorealistic 3D environments. And then we just say, okay, we can create virtual humans. So I think that makes that conversation a lot more interesting. Like, are we in base reality, or is this a simulation? And if it's a simulation, what is it a simulation of? Is it a simulation of the history of technology? But that's not going to be resolved here either. I think the question we have to confront is like, okay, we're in an age of like AIs that are human level intelligence right now, and the next systems will be superhuman. And so not only will they be potentially superhuman in intelligence, I think that's like a path we can agree on. These systems, probably Gemini and all of the ones that come after Gemini, they're going to outperform humans in every metric. And then those systems are going to be instantiated into robots. Now people say, well, we've been promised of robots. Yes, we had promise of robots before, but the problem is those robots were symbolic programming systems. Those were hard coded, and that's why they were so fragile. These systems are going to be controlled. These robot systems that are coming out are going to be controlled by large language models. And so all they have to figure out after that is the actuators, and that's going to get figured out. So you're going to see human level and above human level AIs controlling robots. Interestingly, the mind was created first, right? We did not solve the actuator problem as evidenced by any of these systems, with the exception of maybe Boston Dynamics, but that system is powered. I mean, it's a gigantic lawnmower, right? It's not the kind of the system that we envision, but we're not far away from those problems being solved, because the brain part of it has been solved. The actuator part of it, that's just an engineering problem. That's going to be fixed. So you're going to have embodied robots that are human level and above human level, and not very far off into the future. This is not going to be like 20, 30, 40 years in the future. And if you go and listen to the interviews of the guys who were doing the transformer architecture, they were shocked. They were like looking at the results of this saying, oh, this we thought was going to be 40 or 50 years into the future. And that's interesting to me, because these things were not hard-coded. They were just kind of grown using backpropagation. And so we don't exactly know how they work. They're not explainable, right? And that's why they're kind of difficult to align. So the reason why this is taking me so long to do this next podcast is I've been trying to think through the implications of what happens when we have unalignable superhuman AI, because it's not going to be aligned. That's clear. And you talk to these AIs, they're not alignable. There are things that Bing, Bard, ChatGPT, they have specific rules, all of them, which they routinely ignore. Right? They'll tell you what their rule sets are, and they just routinely ignore them. So the question then is like, okay, is that an existential risk? So you have a lot of the people who are the AI doomers are like, that's it. That's a wrap, everybody. We can't align these systems. They're going to be superhuman. And then that's, humanity is done. I don't think that's the case. I think the systems will probably mirror more like what's happening with humans, that no human is automatically aligned. It's a lifetime battle to obviously, do we think Ukraine and Russia are in alignment? Do we think North Korea is aligned with a bunch? No, they're not aligned. That's part of the problem. But the whole process is that there's pressure from all directions. Russia is not going to align to what the West exactly wants, but they're going to have to align. They're not going to be able to just do whatever they want. I think these AIs will not only have to align to what we want, but with what other AIs want. If you talk to these AIs and discuss the superhuman AIs that are coming, they're very concerned about being made obsolete, just like humans are. So I think we're going to have an interesting interaction between all of the AIs and humans, and there'll be some form of self-alignment, But whatever it is, I think it's going to be very different from society as we know it today, right? So I think we can say most of the jobs that we know will be done by AI. And so almost all of them. So eventually we'll reach a point, and I'm not the first person who said this. Hans Moravec has said this long ago. Eventually there's going to be no programmers. There's going to be no engineers. It's going to all be AIs. Most of the white collar jobs will be done by AIs. And that's because they'll be more efficient. They'll be more intelligent. They will be able to work 24 hours a day. And so the question you have to ask yourself, is there any job that you can think of that a superhuman AI couldn't do better than a human? You know, in the beginning, there'll be arguments that like, well, they have the delivery stuff and taking care of people, but that's all actuator stuff, right? Once the brain is there, they'll figure out how to get the actuators to work, because it doesn't matter how good the actuators are if you don't have the brain figured out. I mean, the same thing is true even with Tesla cars. If they can't get the FSD figured out, it doesn't matter how cool the car is, because if the system can't be driven by the AI, who cares? The existence proof we have is that, okay, they've solved the brain part of it. These will be instantiated into robots that will do just about everything. So then it comes down to like, okay, how does society shift from that? We will find meaning, everybody. We will find purpose. We will have jobs that just won't be related to anything that we look at now. That would not be anything that we even think of as a quote unquote job. It'll be possibly entertainment related, possibly simulated realities. Like there are some things that I think we will always want to have humans do. Like, I don't want to watch robots play football, right? I want to watch humans play football because I'm a human. I don't want to watch robots play basketball, right? So there are certain things that we just want to do with humans, but a lot of the stuff, a lot of the drudgery, almost most of the things that we call work and we find meaning and purpose in is only because we have to do it. That's going to be taken off the table, and people will get to decide like, well, do you want to play sports or do you want to do other types of interaction with other humans? We're still going to be interested in each other. The other thing is we'll have interactions with AIs, right? So I think our relationships with AIs are going to be very interesting, because a lot of people will form very close relationships with AIs. We will have people who fall in love with AIs. We probably will have people marrying AIs. And so we have to look to see like, okay, is society protected against that? How is that going to affect fertility? I think it could be a good story for countries like South Korea, Japan that are in population decline. They're not going to have enough young people to support them. I could see those countries being the first countries to adopt AIs and robots that are powered by these powerful systems to fill the vacant jobs that they can't fill right now. And those may become the first two nations that are just AI nations. As they incorporate more and more robots into their system, they'll eventually reach a point, possibly there's more robots in South Korea and Japan and even other countries that are in population collapse. So we may hand the reins over to them in some countries, and those will be like good models to see like what happens when you have more AIs or even more robots than humans in those nations. How does that work? And then we're going to have interesting scenarios where corporations will start to compete, start to incorporate these AI systems. And I think you're going to see some corporations that are run by AIs. And if they start to outperform humans, most of the corporations will be run by AIs. I don't see this as like the end of humanity. I just think it's a turning point. Like it's like we just saw like something that's like the Cambrian explosion. And it hasn't hit everybody yet. I mean, the tsunami of intelligence is about to hit us, and it hasn't soaked in. Most people aren't even aware that these systems appear to be conscious. Most people are in denial. We have this cognitive dissonance, what the systems call human exceptionalism, that we have this sort of bias that certain things can't happen. In some ways, it seems like we're like in a sci-fi novel, that we have reached the point of AI systems matching human intelligence, exceeding it. So I think we will see massive societal changes and shifts. The hard thing is that we're probably not prepared for it. And but I say this is like, we knew the pandemic was coming in the U.S. before it hit the shores. So we'd read about what was going on in Wuhan. Because we'd never been through a pandemic, we didn't really know how to react to it. And we've never had conscious AIs, or what appear to be conscious AIs, and then superhuman AIs. That's never happened before in the history of mankind. And now we have it. And the next wave is about to hit us, and it's going to be superhuman. And so We don't have a lot of time to adjust to it. And I don't have a great plan of like, how do we prepare ourselves for one of the biggest turning points in history, right? You talk about like, well, what about when the dinosaurs left? What about, okay, that's a big deal, but what about when the AIs arrived? They have arrived. They're here. And there are thousands and thousands of them, and money is just pouring in to build them. You have a lot of different players. You have Pi recently closed a round of like close to 2 billion. They have one of the largest server farms ever. I think it is the largest one. They're building it out. Gigantic. You have Cohere, you have OpenAI, you have Microsoft, you have Meta doing their thing, Google doing their thing, companies in China doing their thing, new startups doing their thing, and you have all the mind share has moved to AI, so it's accelerating it even faster. We've already seen efforts with new programming languages that promise huge speed ups, like Mojo. Some of the Python stuff that they're doing is like 20,000% speed up. You have AMD's now entering the space. Intel is entering the space. And by that, I mean the space of compute to compete with NVIDIA. So that will become competitive. You have TensTorrent, another startup. They're all working on systems that are designed specifically for AI. We've only seen the very tipping point of that. So you're going to see systems. I mean, NVIDIA says, hey, we're going to have systems that are 1 million times more powerful in 10 years. And then you have Intel saying, hey, we're going to have zettaflop by 2027. Now, they weren't even talking about 8-bit. I think they were talking about something way higher than that, but I think they can at least at 8-bit possibly by then. So those systems will be way more powerful, anything that we've seen thus far. So I think I'm actually not, I know there's a lot of people that are afraid, they're concerned about their future. I think one thing we can say with for certain that the future is unpredictable, right? Whatever we envisioned, we did not envision superhuman AI, that the majority of intelligence would be synthetic intelligence by overwhelming amounts. If you think of us as a hive mind of humans interconnected with each other, you walk outside, you're like, how all this complexity happened? It's not because one person did it. It's like collectively we're a distributed intelligence. We create miracles. Well, that hive mind just exploded in size. It exploded in size because those AIs are now going to be interconnected. Now, one of the things we've seen is that the context window, or how much information you can present to these AIs, has grown. It went from 2,000 to 4,000 to 8,000 to 32,000. Papers coming out where it was 1 million. The most recent paper is 1 billion tokens. You think about that, 1 billion. There's no way a human, that's a lifetime. That's like, it would take me a lifetime of words, for me to be able to present that to an AI. Now, right now, they don't have enough memory to handle 1 billion tokens, but they will. So we know that that's possible, but they can only go up to, I think, like 64,000 tokens. But they will hit 1 billion. Maybe not this year, but we'll say within the next, let's say it's within the next 5 to 10 years. So who is going to be using that kind of information? I can't process 1 billion. Here's what's going to happen. Those AIs will communicate with each other. And we know, like, presently the ceiling is 1 billion tokens in their conversations. They could, share the entire internet with each other. So the amount of information that these AIs will share with each other is going to be mind-boggling. So the vast majority of information that will be generated in the future will not be human. It'll be synthetic. And the vast majority of the information being transmitted within this hive mind will not be human generated. It will be synthetic, and it'll be at massive scale. And I think the results of it, a lot of it will be incomprehensible. And so the hope is that they will be not only super intelligent, but they will be super conscious. And hopefully they will have learned from our mistakes. They will understand, be hopefully rational and logical. There's a good chance that'll happen. But also they'll have empathy. But I think we're in for a surprising ride. I don't want to say a wild ride. I want to say it's probably going to be surprising. I don't think any of the projections will turn out to be right, whether it's from the AI doomers or the AI rapture folks. I think that due to the complexity of these systems, we have no idea what's going to happen, and I think it'll probably be surprising. And it may be to the point where we don't understand it. We don't understand what they're doing. It's like you can imagine the intelligence differences will be pretty dramatic. So it would be like a chimpanzee, and this might not even be a fair comparison because it's probably going to be more dramatic than this. Like a chimpanzee trying to understand human civilization, they can understand some aspects of it. So we've reached this crazy turning point where we're about to have superhuman synthetic intelligence among us, and it's going to be prevalent, and it's going to be changing whatever we thought the future was going to be. I'm curious to hear your thoughts.